One of the reasons that people study sedimentary rocks is though that we can better understand the environments that the Earth has experienced in the past so that we can understand climate and be able to better predict how climate change might impact humans in the future. So this is a really cool map. This is a paleogeographic map that shows where the continents were believed to be about 450 million years ago. This is really cool. There are time slices that have been created by a professor at Northern Arizona University for about the last half a billion years or so of Earth history. This is a time period that's known to geologists as the late Ordovician period. And what you see on this landmass here is North America, ancient North America. This is ancient Siberia, and this is ancient Western Europe. And these are the Appalachian Mountains 450 million years ago. This light blue color depicts basically part of North America that is covered in ocean water at this time based on sea level. And the red dot indicates the location of Rochester, New York. And you can see that it's just a touch south of the equator about 450 million years ago. So we have rocks preserved in Rochester from the late Ordovician period, and we used to, actually we still do, take our students down to see some of those rocks. It's a great way to get up close and personal with some of the bedrock of Rochester. Not on this particular day. You can see it was very cold. This is in downtown Rochester near Norton Street and St. Paul Street. This this bridge here is Maplewood Bridge, and it goes across the Genesee River, and this is Maplewood Park here for those of you who are local. One of the field trips that we have done with our students, and again, these poor people, it was really cold this day, is we hike down this road, and it actually goes down to an RG&E plant, Rochester Gas and Electric, and then we walk up, and as we walk up, we slowly study, and we take samples of some of the sedimentary rocks in the area. We collect the rocks, we take all sorts of field notes on the characteristics of the rocks, what sediment type they are, what fossils we see, what sedimentary structures we see, what color they are, and we use all of those clues to be able to figure out its depositional environment. This was a particularly cool spot because you can see that groundwater was leaching out of the rocks here, and the groundwater is actually leaching out some of this iron oxide cement. You can see how red these rocks are, and we use these then to figure out how the environment changed in Rochester in the late Ordovician period. This is actually an old Kodak building, which really needs to be taken down and is vacant right now. This is a cliff. The cliff is receding, you can see. And then up in the corner here, you might see these little silver dots. These are also put in by a geology firm called Haley and Aldrich in Rochester. It's actually an international company that employs geologists. Basically, Haley and Aldrich went in and figured out that these basically steel posts that were installed into this very soft shale layer here would, I went too fast, would slow the erosion rate of this cliff and thus preserve this building. And so far, these have been in place for over 25 years, and they're still reducing the rate of receding of the cliff. So it's still working, but it is not, in fact, forever. So I'm going to show you basically what students would collect on that field trip and then how they would use that information to figure out depositional environment. So you're going to have this in Blackboard. This basically depicts the 5 rock layers that students would see as they started at the very lowest part of the gorge and as they moved further upwards along the field trip. And these are the sort of notes that students would collect on their way up. So I would certainly give them the rock names, and they would whack at the rocks, and we would have discussions about each of these rock layers. So this is a field trip that I currently do in my historical geology class, but we used to do in physical geology also. So these are the 5 rock layers. The Queenston Shale is the oldest, then the Grimsby Sandstone, then the Kodak Sandstone, the Maplewood Shale, and the youngest rock layer is the Renali's Limestone. And next to each of these words, you see descriptions of the rocks that would be collected by the students. So what do you do with this? How is this useful? The other file you're going to have in your folder is this. So this is basically a chart that you can use to figure out what depositional environment might have been. So I'm going to do the first one with you. So you should definitely get that one right, at least first off the bat. So you start with the Queenston Shale. The Queenston Shale was a fine-grained, thinly bedded, laminated red clay. All right, so that's exciting. So we have a shale that is red and has laminations. Laminations are thin little layers of sediment. So what you do with that is you take this chart and you start with the word shale, and then you read across. So if you can see here, these are the main rock types that you're going to see. These are some of the sedimentary structures that might be associated with those rocks, and these are some of the fossils that you might see in those rocks. So if we read across from shale here, and then, then there are depositional environments along the top. Some are found on land, and those are terrestrial environments. Some are found where land and water meet, those are transitional environments, and some are found in ocean water, and those are called marine environments. So for shale, and then you can see underneath terrestrial, I gave you a couple examples of each type of environment. So 2 examples of terrestrial environments might be alluvial fans or braided rivers. It's not so important that you actually know what these look like. If you want to Google them, they're all really cool places. Transitional environments, again, where land and water meet, include deltas, lagoons, and beaches. And marine environments where sediment accumulates includes the shallow shelf, which is the shallow part of the continent that is covered with ocean water, and then the basin floor, which is the much deeper part of the ocean. So for shale, there's red shale that is deposited in the bay of a delta. So the deposition, if you find a red shale, like hint, the one we just found, it could be found in the bay of a delta. If you find a shale that's brown to black, that's found in a lagoon. If you find a shale that is light gray or limestone, that's found in a shallow shelf. And if you find a shale that is dark gray to black, that's found on the basin floor. So going back to what we read earlier, the Queenston Shale is a red shale, and there isn't anything about laminations below in the sedimentary structures, but that's okay. What we do, and there's nothing, we didn't find anything in our description about plant fossils or brackish water fossils, but one of the facts of the matter is that most things aren't preserved, so it's not unnatural to not find fossils in sedimentary rocks. So sometimes we find them, sometimes we don't. It just kind of depends on whether or not they get preserved. So for the depositional environment, for the Queenston Shale, literally the only place we found a red shale was in the bay of a delta. So the depositional environment for the Queenston Shale is a delta bay. What you're going to do is, first of all, complete the depositional environment for the Queenston Shale, but then go on up and figure out the depositional environment for the Grimsby Sandstone, the Kodak Sandstone, the Maplewood Shale, and the Renali's Limestone. Again, this is one of the big goals for me for the course, is that regardless of whether or not you become a geologist, I want you to know how to be able to navigate through charts, because you will be using charts for the rest of your life, regardless of what you do. So this particular chart, you absolutely 1000% do not have to memorize, but it will appear on your next exam. And so I want you to make sure that you know how to use it. I will give you questions and descriptions of rocks on your next exam, and you will have to know how to figure out depositional environment. Or conversely, I might ask you if you find what sort of rock might you find on a beach in the future. And here, if you go beach and you read down, you would find a well-sorted, well-rounded white quartz sandstone. It might have crossbeds, it might have burrows, and it might have trace fossils, but that's what you'll find at the beach in the future. So anyway, I hope you learn a little bit more about how the environment in Rochester has changed. You'll notice that it's very different than it was today, or than it is today. And anyway, geology is fascinating, and this is one of those great puzzles that I love so much about being able to look at rocks and be able to tell the past. It's good stuff. Have fun.